All right, here's an integral that's challenging, and we don't really know what to do with it, but we recognize it as a rational function. It's one polynomial divided by other, and so we can think about splitting it up with a partial fraction decomposition. As I've said, this is just splitting it up using the common denominator process in reverse. So the real question that we have to ask is, what is the most general set of things that could combine to give us this common denominator? What could give us x times x squared minus 1 as a common denominator? In order to answer that question correctly, we need to recognize that x squared minus 1 is actually x minus 1 times x plus 1. So we need to factor the denominator completely in order to answer this question. So now I have the denominator completely factored, and I want to know what combination of things would give me that as a common denominator. And the answer is, well, we'd have some fraction with something over x and something over x minus 1 and something over x plus 1. And if I had that as a fraction and I wanted to combine it with a common denominator, I would get back to x times x minus 1 times x plus 1. So that is the form of our partial fraction decomposition. We're going to look for an a, a b, and a c that will make this equation true, that will lead us, that will allow us to break down our original function into these different parts. Now the way we do this is we're going to multiply the equation by the common denominator. So multiply everything through by the common denominator. That cancels the common denominator completely on the left-hand side. And on the right-hand side, different parts will cancel. So we'll have a times x squared minus 1 plus b times x plus 1 plus c times x minus 1. In each one of those terms, some part of this thing is going to cancel and some part is going to remain. So now this is our equation. Now this is true for any value of x that we could choose. In particular, so this is true for any x. So let's pick some. Let's pick x equals 0. And if I pick x equals 0, this equation has to be true for x equals 0. If I pick x equals 0, what do I get? I get 1 equals negative a plus 0 plus 0. So I know that a is negative 1. It's another value we could pick for x. Let's pick x equals 1. If I pick x equal 1, then I have the equation 1 equals 0 plus b times 1 times 2 plus 0. So I plugged in x equals 1, and I get the result b equals 1/2. And I can also pick x equals negative 1. If I pick x equals negative 1, looks like I'm going to get a 0 here and something else in the other places. So picking b equals, or x equals negative 1. Oh no, I get a 0 here as well. So 0 here and here if I pick x equals negative 1. And that leaves me with c times negative 1 times negative 2. So I have 1 equals c times negative 1 times negative 2. So c equals 1/2 as well. And so back to our fraction, 1 over x times x squared minus 1, the integral of that is equal to the integral of a over x. A was negative 1, so minus 1 over x plus 1. Let's write it like this. 1/2 over x minus 1 plus 1/2 over x plus 1 dx. And now we have this integral in a form that we are comfortable with. So this is going to be a negative natural log of the absolute value of x plus 1/2 times the natural log of x minus 1 plus 1/2 times the natural log of x plus 1 plus c. And we could combine these terms with log rules, but there's really no need for that. So we're going to leave it like this, and that's our final antiderivative.